Okay, in this demonstration we want to look at how to do one-way analysis of variance using RCommander. Okay, so first of all I'm going to load the data. I'm going to import data from text file. Again, it's a comma separated values file. It's just going to be called dataset when I load it. I click OK. The dataset we're interested in is called Lichen 4. Okay, so we click on that and open it. If we view that dataset, we see that we have a dataset that has a tree identifier. We'll just ignore that for the time being. A side, which should be, if I make the window a bit bigger, north, east, west and south, and a lichen measurement for each of those. Okay, so there are 40 observations in the dataset. And the first thing I want to do is a box plot against the groups just to see how it looks. So there's lichen is going to be my response. Side is going to be my group variable that sets up the box plots. I click OK, OK again. And there we see a box plot for each of east, north, south and west sides. Okay. Doesn't matter what order these are in this CSV file. R tends to put these in alphabetical order when it then deals with things. The first thing to do then is to just do a one-way analysis of variance. If you go to the statistics means submenu, you can see one-way analysis of variance. Again, we get to choose the grouping variable. We're just going to use side, and we've got the lichen as the response. There's a little tick box here about pairwise comparisons of means. We just leave that alone for the time being. Click OK. Alright, and then down the bottom we see an ANOVA table here in blue. Okay, it shows us the degrees of freedom for side and residuals. It shows us, which is corresponds in our case to the error degrees of freedom. It shows us the sums of squares for those. It shows us the mean squares, the F ratio or F value, and the P value for that. You can see for this case the P value is 0.202, so we would not call that significant at 5 or 10%. Okay, it doesn't have a row in the ANOVA table for total. That's just the sum, remember, of the total degrees of freedom is the sum of the other degrees of freedom, and the total sum of squares is the sum of the other sums of squares. So we're not so interested in those. Okay, it also produces a table of means and standard deviations and sample sizes underneath. You can see that. It's just for your reference. If we look at those standard deviations, they all look reasonably similar, not too different. So there's no real strong belief there that there's a difference in variances. And remember that one-way analysis of variance assumes equal variances. Okay. That's the end of this demonstration.